Let's look at the solutions of modern maths bites. Sharma's family, having 2 adults and 1 children, and Mishra's family, having 1 adult and 2 children, are to be seated in a row. If all the children need to be seated adjacent to each other, and the 2 adults of Sharma's family also need to sit adjacent to each other, in how many distinct ways can the seating arrangement be made? Okay, I'm doing this. Sharma family adult 1, Sharma family adult 2, Sharma family child, Mishra family child 1, Mishra family child 2, Mishra family adult. Now we know these 2 have to be together. We also know these 3 have to be together. This person is free moving. So these 3 groups, they can be rearranged in 3 factorial ways. Now within the group of Sharma adults, they can be rearranged in 2 factorial ways. And within the group of children, they can be rearranged in another 3 factorial ways. So altogether we get 6 into 2 into 6 or 72 total ways. Answer should be option A. Next, a study is being conducted about the number of bank accounts held by individuals. In the target group of 90 individuals, 20 have an account with HDFC, 50 with CICIC, and 65 with Axis. Further, 30 have account in both HFDC and CICIC, and 35 in both CI, blah, blah, and blah, blah. Find the maximum and minimum number of people in the target group who can have accounts in all the 3 banks. So this is an example of a constrained maxima minima. Let me go ahead and create the Venn diagram. Now this is HFDC, total of 60. This is CICIC, total of 50. And Access, total of 65. We are told this here for 30 have account in both HFDC and CICIC. So 30, 35, and 40. If I take the central value as X, this will be 30 minus X. This will be 35 minus X. This will be 40 minus X. So this region here will be X minus 15. This region here will be X minus 10. This region here will be X minus 10. But never forget, there is also a region on the outside that you have to take care of. This is 65, 30, 10. So 5, 70 plus X. So the region on the outside is going to be 90 minus 70 minus X, or altogether 20 minus X. Now see, all these regions are supposed to be count of people, and count of people can only be a whole number, has to be a whole number. So effectively what we've got is X has to be greater than equal to 10 and X has to be greater than equal to 15. Based on these 3 expressions, we've got the condition that X has to be greater than equal to 10 and greater than equal to 15. Between these two, of course, this is the stronger condition. So X has to be greater than equal to 15. This we have got. Similarly, based on these conditions, based on these spots, what we have got is X is less than equal to 20, X is less than equal to 30, X is less than equal to 35, and X is less than equal to 40. So altogether, what of these, the strongest condition is this one, X is less than equal to 20. Why I'm saying this is the strongest condition is, if this condition is met, everything else is automatically met. So the range of X that we have identified is 15 to 20. Therefore, the answer should be option C. Next question. There are 10 points in space, of which 5 points are in the same plane. Apart from these 5, no other 4 points are in the same plane. How many different planes are present in the space that have at least 3 out of these 10 points? Now see, in order to make a plane, you need 3 points, because 3 points will give you a flat surface, a 2D surface. So if you had only been told 10 points, you would have gone 10C3. But the problem is 5 points are in the same plane. So there will be a lot of overcounting taking place. So let's get rid of that overcounting. 5C3. But those 5 points are present in one plane. That one plane has to be counted. So add that back. So you get 120 minus 10 plus 1. Altogether you get 111. Option C. Next, a circular table has 8 equispaced chairs around it. The chairs are all identical except for their colors. The colors of the chairs are alternately white and black. In how many ways can 8 people be seated around this table? Okay. When the first person walks in, he can choose his seat in 2 ways. He will either sit at a white chair or on a black chair. He'll either sit on a white chair or on a black chair. And after the first person is seated, now all the 7 remaining chairs are distinct. You have 7 distinct chairs. You have 7 distinct people. That can be done into 7 factorial ways. So the total number of ways in which 8 people can be seated is option C, 2 into 7 factorial. It's a very theoretical question. There is no maths around it. Last question. How many 6-digit numbers exist which have exactly 2 zeros and at least 2 ones? Okay. We'll have to work with cases. So case 1, I have 2 zeros, 2 ones, and 2 others. So let's say if it was a 6-digit number, my first constraint is ensuring that zeros don't end up in the leading place. So among the following 5 places, zeros have to take up 2 spots. Done. Now spots for 1 I can choose out of 6 spots, 2 are already used up for zeros. So 4 spots are left. Out of those 4 spots, I select 2 for where ones will be placed. That is done. Now I have 2 empty spots, and on those 2 empty spots, any number can come. It could be 2 repeated numbers or it could be 2 distinct numbers. Doesn't really matter. They can be filled up in 8 into 8 ways. So here, what do I get? 10 into 6, 60, 60 into 64. 64 into 6 is 384. So this turns out to be 3,840. This is case 1. Second case is 2 zeros, 3 ones, and 1 other. Here, again, I will pick spots for zeros first. Then when I'm picking spots for ones, I will pick 3 spots out of the remaining 4. And the last spot can be filled up by any number in 8 ways. So 10 into 32 gives me 320. At this time itself, you can hopefully see we have reached 4160. We have already reached 4160. So answer has to be B. But in case you are looking for comprehensiveness, last case would be 2 zeros and 4 ones. 2 zeros and 4 ones. You only have to select the spots for zeros. You can do that in 5C 2 ways, which is equal to 10. So when you add these 3 numbers up, you will reach a total of 4170. Answer is option B. That will be all for this episode. Hopefully you learned something. Okay, bye.